Okay. We are going to talk about the cubic function. Now we turn this on. See, I've already wrote the. Well, let's see. See, you write something like this, okay? Let's clear and write it here. X to the power of 3, and then you move this one here to come to write the rest of it, minus 2x minus x plus 2. We are going to graph this one. So let's see. I'm sorry. See, this has to be x squared. So what you do, you go up here and push second, insert. You have to put to the power of 2. Oh, wait. Let's write it. Let's clear all this. See, x to the power of 3 minus 2x to the power of 2, and then minus x plus 2, and we graph this one. See, here we say that it's not it's really hard work if you want to, you know, give value the traditional way of finding the points and then connect those points. But x and y here, x3 or something here, we give value to x like, I don't know, -1, and you find 0, x, y, whatever it is you find it like this one. Let's find this -1. -1 to the power of 3 minus 2 times -1 minus -1 plus 2. See, instead of x we put -1, and it's going to be -1 here, and it's going to be +2 here, and it's going to be +1 here and +2 here. Okay, to the power of 2. Oops, I'm sorry, to the power of 2. So this is going to be 1 minus 2. Minus 2. This one, when it's squared, it's going to be +1. You know, -1 times -1 is going to be +1. Because 1 times 1 is going to be 1, and the minus times minus is going to be positive. So it's going to be 0. And x is equal to. So this is hard, you know, to find all the point -2, -1, 0, +1, +2, or +3, you know, and then it's really hard. So you won't do it by hands. You just use calculator. You just use calculator to graph it. So at this point, we can find all these maximum, minimum, and all these. I'm going to show it to you here because you're going to use this all later in math if you want to study engineering or some other courses that they need higher math, you know. So first let's find the zero of this function. Second, trace, and then zero. Okay, and same way. Okay, the first zero which intercept the and then you go to the right side of it, enter again, and you see this x minus 1 is 0. X, when x is the coordinate of this one is minus 1, and see every point has two coordinates, x and y. We can't find any point that just one, either y might be 0 or x0 or whatever, but they have x and y. So we find the 0. Now we want to find the maximum point that the y has. You know what I mean? I mean the vertex of this curve, which we call it maximum. Second, trace, and then you come to maximum here, enter, and then it asks you for the left side of the, this is the left side of the, you know, left side of this point, enter, and then you go to the right side of the point, enter, and then it tells you x is minus 0.2152 and whatever, and y is 2.11. See, this point has a vertex. It's talking about this right now. We find this one is minus 1 and 0, this point A, and in this one, it's the relative, we call it later on, we call it relative maximum, is the coordinates is B, but some decimal numbers, minus 0.215 and minus, because it's here, minus 0.215. And then the y is going to be this much here, from here to here, is going to be positive, but 2.11. 2.11. At this point, we have the maximum. And then, you know, you go through this one here. So when you can say this one, you know, value, and say like 1 of x0, and then it's going to be y2. So at here it intercepts y-axis, because x is 0 and y is going to be 2. I guess it was 2, yeah. So and then you go forward to find another intercept. There are two more. This one has intercept the x-axis in 3 places, and so we go to this one. You say we find the 0 of this one here. The next point is the left side of it is here, and the right side of it is right here, and then enter again. It's a 1 and y, x is equal to 0. X is 1 and 0, the point C, here, this point B, point C is 1 and 0, x1 and y is 0 for sure. When it's on the x-axis, the y is always 0 when you have point in the x-axis. So you continue. So we find the zeros of this, because you know later on in mathematics they want you to find the 0 of this function, where intercept and where the answer. The answer is, you know. So we go to the next one. Is going to be minimum. Find mean. See, this is the minimum point that it's going to get upward, up, opens up, and it say ask for the left bound of this, and let's find this point too, and the right bound, and then we say minimum is 1.27 minus 0.45. 1.20 rounded 1.2 1.270 7 and minus 0.46 minus 0.46. So this is here the point D has x 1 here 1.277 and y is going to be minus 0.46 from here 0.46. So and then the other one too, here we go, you find the 0 again, find this and go to 0 and then go to the left side of the 0 and to the right, and then again x is equal to y is equal at x is equal to here y is equal to 0. This is another intercept point. Okay, so this is the cubic function. It has maximum, minimum, and in quadratic we just had the maximum or minimum. This one we had both maximum and minimum. We can find the coordinates of this point at the top. What is this? And the maximum gives you all the x coordinate, y coordinates, and all this. So the cubic function look like this. If we suppose that we put a minus sign here, it's a negative, insert minus. So this is, see what it was going to be look like. See, if you put minus, it's totally different from the things, the other one that has a positive x to the power of 3. Okay, let's clear this. Let's get back to this. Sometimes you have equation like this, and you want to give the value for x, and you want to find the different point of that function to graph it. So you can write here the equation. You can write here. You say x to the power of 3, and then you go up down here, minus 2x squared. The same equation, minus x plus 2. Okay? See, when you enter, you put something. Actually, we defined x before. What's the value of x that it was in there? It's 2.5. They put 2.5 in there and find x. At the top you see x cubic minus 2x squared minus x. If you put the value for 2.5. You get the value for y. This is y. So suppose that we and this equation we had something like we put something like here x minus 1, for example, x minus. What you do, we say minus 1 store at x. So what is the value of x? You say value of x is minus 1. Oh, now you put this, you go back there, and when you push enter, we highlighted enter, it's going to write down the same equation at the at this line. It's going to write this equation. Now we say give value to x is equal to -1. What is going to be? It's going to be 0. See here? X is -1. We give value to x -1 and y is going to be 0. How about we put something here is -0.5. What is going to be? It's going to be, see, the maximum point is 211 here, so this is going to somewhere like that, -1/2. You find the value of y. So you put -0.5, store x. Now value of x is -0.5. Okay, and then you bring that equation again. You come here and highlight it and enter. It's going to write that equation again. Maybe we made some mistake and we're going to change the -2 to +2, whatever. You can do that. You can go like if you want to write it 3, you can write this and find the answer. But we let's use the same equation. Now we are going to find the value for is 1.875, almost 1.9. See here, if we write it in a scale, see, it was at 2 plus 2 here, we have y-intercept. Now we choose a we choose 1.5 here, okay, minus 1 half. Then we said what is going to be the value of x. 1.87. 1.87. No, actually, this is intercept. X is equal to 2 intercept. So you can find any point here that with this method you give the value for x and you find the value for y. So that's the best way to write you see, when you see something like that, you know, x to the power of 3 and this one is power of 1, but we don't write it. If you see something like this, instead of just putting the numbers in it, you just use calculator. It's really hard. It's really hard to find, first of all, the maximum and minimum, you know, and all those. The best way is to write the equation in this form here, and then find anything, you know, any value for y. So I was going to tell you also about the if you have something like a quadratic equation. I forgot to talk about it. Let's use the same equation here, 2x minus 50. Okay, and we are gonna what I'm trying to say is first of all to tell you how we find the answer of this. Answer of this is going to be either we know that it's x, multiplied is going to be minus 5 plus 3, because minus 5 times 3 is minus 15, and you add them up, it's going to be minus 2. But we know the answer is going to be x minus 3 and x plus 5. Mean it will intersect it's something like that, plus 5 minus 3. Okay, we're going to use here, we give the equation to, see, you use application, and then you come down here, number 9, PLYS, okay, and then enter, and then you use this one here. See, it asks you what degree of this equation is. We are gonna use this one. The degree is 2. So everything okay. Okay. We want to write it in real number, the fractions. You don't change these other things in degree, and then you push next. It asks you for these. It asks you for here for the A, B, and C and D. This is A. A is equal 1, B is equal minus 2, C is equal minus 15, because the general form AX2 BX plus C. A here is 1. So we put this all in the system. We said A2. It's just putting the reverse side of it. It's A2. The coefficient of x2, and A1 is this one, minus 2, and A 0 there is C. So we give all these numbers to this to see what is gonna be. A2 is 1. We say 1. And then we go to A1 is minus 2. And then A0 is minus 15. And then you solve. It's going to be 5 and minus 3. It gives you, we just find out, they say that this is x minus 5, x plus 3. That's why we got this. So x is equal to 5, x is equal to minus 3. It actually gave us those 0 numbers, 0, at x is gonna be so what is showing here, it actually they're telling you, if you put this one in this calculator, and then the procedure I talked to you about, you give the value for this one, and then it gives you the answer. What are these? It's going to be plus 3 minus 3, plus 5 minus 3. It's going to give you the answer where intercept what x-axis, y. So this is another way to find the roots of this quadratic. So let's no, the other example we had. See, we are using the same example again and again because just want to let you x3, x2. You remember this equation that we already worked on it, and now see what. So what you go to main, push this one to main, and then it's see, whenever you see something like that, quit. It's at the polynomials at the number 6. You push enter, and you come back to the original screen, or you say quit. So let's write this. Let's clear this one, and we do the same thing. We come to polynomials, number 9, and then enter again, and then push enter, and then you accept it. You go next, and then you give the value. The first one did change. It didn't change very much. The other things, you just -1 here, and then solve. They said no roots. You know what I mean? What is no roots? When we draw this one, here was something like this. Okay? If intersect this one, or whatever is upward or downward, intercept at x-axis. But here, this one, the last equation we read said has no roots. Means it doesn't intercept. No interception, no x interception, no x interception in any side. So it means has no root. Doesn't have any root. But the other one we talked about that is plus this one has a root of +5 and -3. And when it's positive, it's gonna be like this. Now, if you want to find this one, you use -b over 2i to find the value of x and give it value of x to that original equation. You find the value for y. So that's it. I think. See, let's find that -b over 2 for this one. -b over 2i is equal -2 times -1. 2 minus 2 is going to -1. So the point of x is -1, and you put it in there. No, this one was minus. It's something like this. It was something like this.